So basically, we're going to go through the mathematical modeling cycle, and there are, you can kind of see this diagram, which I want you guys to kind of write out, because once again, we're doing some active listening, trying to take some good notes and whatever. But you can see we start, basically, we're going to start with a problem. And we need to define, basically just defining the problem. Then we're going to formulate what we think, we basically formulate a mathematical equation or something like that to determine what the model is. And if you want to, you can just write out like this problem formulate. You don't have to do the definitions yet, because we'll go through the definitions of each. So after we formulate, we're going to compute to determine basically what our answers to the problem would be. All right, mathematically. So basically we identify the problem, then we try to put the problem into math terms, then we compute those math terms, then we interpret what the math terms mean, what our answer from the compute stage meant. So in other words, we start with a real world problem, put it in math terms, compute those math terms, and then interpret what that meant, what our answer was. Then we validate it. Validate by looking, making sure that our answer lines up, makes sense, basically. And after we validate it, then we report. Now, you'll notice that these four squares are kind of interchangeable. These four squares right here are interchangeable. And now this is looking like a hot mess, but you get the idea. These four are interchangeable because let's say you interpret the data and try to validate, and validation doesn't make sense. Right? Well, then go start the process over again. Maybe our formulation wasn't quite right. Maybe there's something in here that isn't going to work. I want you guys to get out of the idea that you have to get it right the first time. Okay, this is a process. All right, so let's talk about the problem. Okay, so when we're talking about coming up with the problem stage, which is what you guys should be writing down, a problem just identifies variables in the situation to represent essential features. And that's literally all you have to write down. We're going to use an example for this, but this is what identifying the problem really is. Okay, you're identifying variables in the situation to represent essential features. So let's take an example. All right, so examples: two phone companies charge different amounts. You don't have to write all this down. Two phone companies charge different amounts for plans. Company one charges a monthly fee of $30 plus 0.5 per minute. Company two charges a monthly fee of $20 plus 0.75 per minute. Okay, so in this case, the variables is we can look at what company one charges. So like we use C1 will be our company one. We could have used X or Y here, but that's fine. C1 is the first company. C2 is the total monthly cost for company two, right? And then M would be number of minutes in this case. And that makes sense for those to be those variables, because we can say company one is in terms of this, company two in terms of this part right here. So just identifying what those variables are is kind of the first part. After we determine what the problem is, then we need to formulate. Basically, you're going to develop a model by creating and selecting representations that describe the relationships between your variables. So for problem one, the first part of the problem, we identify what the variables are. And Formulate, we're going to come up with an equation or some kind of representation of the relationships between those variables. So remember, in the problem, we decided that our variables would be C1 for company one, for the cost of company one, C2 would be the cost of company two, and we decided that M would represent how many minutes, right? And so we've created these $30 for That's our base cost, if you'll remember the problem. And 0.5 minutes was how much? It was 50 cents per minute, right? It was $30, base fee of $30 plus 50 cents per minute, right? And this is a linear problem, right? Because it's, it's consistent, it's per minute right here. Same thing, company 2 was $20 plus 75 cents per minute. So if we go back here, you can kind of see where we got that from. 20 plus 70.75 per minute. So we've established C1, C2, and M, and now in Formulate, we have created equations using those variables that we found in the first part. All we've done at this point is identified what variables we have, which in this case are company 1, or how much company 1 charges, how much company 2's charges, and we've identified what both of these are based on. What both of these outputs are based on is minutes. So we have C1, C2, and M. Everybody understands where those come from, right? Company 1, company 2, and M. After we decided on that, then we took those variables and created a mathematical equation, or a set of mathematical equations from that. So it's 50 cents per minute, 0.5 per minute, plus $30 base charge for company 1. And then 75 cents per minute plus $20 base charge for company 2. So now we need to compute. In this case, we'll compute through graphing because it's just going to be easier. We got two linear objects. And we use Desmos here. It's very helpful, at least visually representing or understanding what's going on. Last week in problem 1, we didn't use Desmos mainly. We mainly used Google Sheets, right? Because it did the same thing for us. It computed a lot for us. And in this compute phase, we're analyzing and performing operations on the relationship to draw a conclusion. All right, so when we're in the compute phase, we're analyzing and performing operations on the relationships to draw a conclusion. In this case, we graph both equations. All right, we can see the red one represents company 1, basically, and the blue one represents company 2. So I'm gonna go back and make sure everybody's got everything. So the first thing we did is we read the problem and we decided what variables to use. C1 for company 1, C2 for company 2, and M for minute. Then we created equations based on those. So we said C1 plus 30, or C1 is equal to $30 flat plus 50 cents a minute, and C2 was $20 flat plus 75 cents a minute. Then when we get to the compute phase, we actually just put both of these into Desmos. We'll find that most of the time we will use some kind of computer program to compute things, but we could also compute these by hand. We could have created a table of equations if we wanted to, table of values to compute. And now we're going to interpret the data. So, well, we're going to interpret what we computed. So if I wanted to find the equilibrium point, in other words, if I wanted to figure out where these two plans were the exact same, okay, then that would be this point right here. They cost the same if you use 40 minutes, right? And they'll both cost $50. Everybody cool with that? So at 40 minutes, they will cost $50 each. That is me interpreting the data. The data point is actually 40/50, right? That's it. That's all the computation actually gives me. So if I said, hey, where's the equilibrium point? You could graph the two things and just look, oh, where do they connect? Or for linear systems like this is, we have substitution and elimination, right? Y'all have used substitution and elimination before several times. We could use that to determine where the equilibrium point is. We could, but in this case, we just graphed them and we said, okay, we got 40/50. well, what does this mean, right? Because 40, 50, those are just numbers. That could mean anything, right? So when we interpret the data, all right, which interpreting is just, and I know it's kind of hard to see on this, but it's gather and analyze the results of the mathematics in the terms of the original situation. Another thing we could interpret from this data, by the way, is we could say things like, hey, up until 40 minutes, which of these plans is cheaper, the red one or the blue one? Which one's cheaper? The blue one, right? Because it's less. You see, like it's less than the red one, right? But after 40 minutes, which one's cheaper? The red one. Can y'all see what I'm saying? Does this kind of make sense? So that's all interpreting the data or interpreting what we've done. Second to last is validate. We're comparing the results of the situation and see if we can improve our model, make sure our model is working. We're looking, does this make sense? Well, yeah, right? Like, y'all remember we did the problem with John and Amy and DeMarcus, whatever. At first, you know, the guy who just was paid more automatically was making more money. But as time went on, the guy that had the higher rate, he made more money, right? As time went on. So it makes sense that being paid more starting out, it would be a higher, like it's the fact that it's $30 versus $20. It makes sense that it would be higher. But as time goes on, let me go back because probably, but you see what I'm saying? It makes sense that you would start off, since this plan is higher starting off, it's going to be more expensive. But since the rate per minute is less, right? The rate of change is less. We know eventually this plan will eclipse this plan. Does that kind of make sense? And so we can go back and think about, like, does this really make sense? Right? Does my formula really make sense? And they're like, yeah, it does. And then lastly, we're going to report. In this class, we're going to be reporting through presentations, but also in you all's first project, you reported by literally just by doing part 3 and submitting. Right? So basically, you're sharing the conclusions and reasoning behind them. So you share your conclusions and reasoning behind them. So the conclusion is, I got you. The conclusion is company 1 is more expensive if you use less than 40 minutes, and company 2 is more expensive if you use more than 40 minutes.